family show. And then without further ado, let me turn it over to Jonathan Schneider, who's going to talk about automated mass refactoring for Java-based applications. And I'm going to stop sharing. And Jonathan, over to you, my friend.
Vincent, yeah, thanks for the kind introduction, and happy to be back here in Atlanta. It's been, I guess, since 2019, the last time I made it to Atlanta. So
2019, man.
2019.
It was you and me, bud.
Feels like, yeah, that's right. Well, I'm here to reintroduce a technology I first worked on at Netflix back in 2016. It's something I'm super excited about. It's kind of a magical, I think, feeling, this capability to do automated source code transformation to affect whole framework migrations like JUnit 4 to 5 or Spring Boot 1 to 2. We've done Quarkus major framework migrations, Micronaut, Cert to CertJ. These are the kinds of things that our team is really after getting done. And we're introducing tonight an open source technology, again, forked from the original Netflix repository called Open Rewrite, just under github.com/openrewrite. And there in Open Rewrite, we've been developing recipes to help you perform these kind of changes on your repositories and take some of the tedium out of your daily life, because there's plenty of that already, and get you back to doing creative things again. So I'll give you a bit of a background, and then the sort of arc here is going to be, we're going to jump in and actually, we've been making PR suggestions to Spring Cloud Dataflow to get them moving towards JUnit 5. Going to do another one of those tonight here live, and then get into a bit of what it looks like to develop a custom recipe to perform a transformation that we don't yet have in our catalog. So I'll start here with the background of where this all began. It was about 2016 at Netflix. There was an internal logging library that looked remarkably similar to SLF4j or Log4j2 or any of the other open source logging frameworks, but it was written internally. It had been written very early in the company's life, and they had, of course, decided at some point, let's just move toward SLF4j, right, and not have this internal thing. So the platform team deprecated it. 6 years later, there's still a couple million references to this logging library left. And it's there at Netflix, there was this freedom and responsibility culture. So it was, you couldn't impose any constraints on other teams. And so, as a platform library, they couldn't just pick a date on the calendar and say, we're going to remove it on this date if you aren't done yet. It would have constrained other teams, freedom of movement. So it just remained, and it was just stuck. And it makes sense if you're an engineer on a product team, you come into work, you've got a bunch of stuff that you're trying to do today. The last thing on your mind is going and replacing logging statements one for another, which was something that looks wholly similar, as long as the other thing continues to run. And that's how it goes in a lot of our code, right? We're sort of confronted with a major change. We're confronted with some technical debt, and we're having to negotiate against the business with to try to deal with technical debt while the business is trying to get us to do feature development, and it kind of has a nasty feeling. I found that you wind up sort of fighting for time to mow the lawn or take out the trash, or pick up your socks, and it's not work that we enjoy doing either. Anyway, this is kind of what it looked like, the original logging library. You have a logger, up top, that get logger. You have an error method call here, but notice there's a couple dissimilarities. There's this almost like string format style parameterization. The error, rather than being last, is second in position. And so it's just, to get this done, we really need to go from this to something that looks more like this, where we've inverted these arguments, where we've changed the parameterization. And it's just hard enough that it's really pretty much impossible to do this kind of thing with like a regular expression, because you see, we're crossing line boundaries, and these can be a bunch of chain method calls. It's sort of arbitrarily complex. So really difficult to do. So that's where we started. We started actually working on a technology that could do these automated refactorings based on an abstract syntax tree. It wasn't the first project of its kind. You take source like this, it's turned into an abstract syntax tree. We make modifications on that tree, and then print it back out to yield that change. It was somewhat unique though because of Netflix's particular culture around freedom and responsibility. There were a lot of attempts at it previously that once you got it from source into an AST, if you printed that AST back out, it would make assumptions about the original formatting of the code. And so as long as you perfectly followed a particular style, it would be, just the change that you made to the AST would sort of come out at the other end. But if not, it could clobber the formatting of the rest of the code. We had seen other projects do AST manipulation, but with ASTs that didn't have all the type information on them. So when we were looking at something like this, I wanted to identify the old Netflix loggers, not the new SLF4j loggers, not log4j loggers. You want to identify a particular kind of logger. And sometimes that information isn't even visible in the source code. I could have imported this logger, but via a star import. So, if you really want to accurately make manipulations, you have to do so on an AST that has type information on it. And then the third thing is we wanted to be able to perform these sort of transformations en masse. So Netflix at the time had about 10,000 repositories and many millions of lines of code. And we wanted to be able to say, if I'm going to propose a change, how much of the code would this change? Would it affect 500 projects? Would it affect 5,000 projects? And so the ability to run it en masse across a large code base was also a goal. So those were some of the starting assumptions. And in the last, I'd say year or year and a half, what our team has been doing is taking that original technology and expanding upon it dramatically. So rather than just doing simple logging statement replacements like this now, we've built up a series of base building block recipes that can do very much a lot more complicated things. And so let's kind of like hop over to a representation of the catalog that we have. We've got a public service now. It's called Modern, and the name of our company. And we have a public service where we've been ingesting GitHub repositories. And we keep adding more repositories all the time. And we're able to run these recipes that we've released to open source on these repositories. So if we start to look at the catalog, we'll look at, say, like Java. We've got recipes that span the gamut from like Spring, Change, Quarkus, Micronaut ones coming out here, logging, testing, modernizing JDK like JUnit 8 or Java 8 to 11, etc. Let's hop into just.
Hey, like John, all we can see is your slide. We can't see your browser.
Thank you, Tyler. Yeah. Browser?
Better.
Okay, thanks. Yeah. So the catalog here, we've taken all the recipes that we have in open source and just sort of listed them here, and we've been ingesting public code to be able to run these recipes en masse. This is an app you can sign up for just at modern.io, and you can play around and issue PRs like we're going to do here tonight. Or you can use one of the Maven or Gradle plugins that we have to apply any of these recipes locally as well on one of your repositories. So if we go and start to like drill into Java, for example, and we look at the testing category, we have a recipe that performs the whole JUnit 4 to 5 migration for you. Of course, that can be really, really tedious. So it's a recipe that does a lot of things. If we kind of look at the details here, recipes are the abstraction in Open Rewrite that performs some sort of transformation. Recipes can include other recipes, so you can sort of build higher and higher order functions as you compose these things together. And you can see that this JUnit 4 to 5 migration involves things like reordering the method arguments here changing types, changing dependencies and so forth. So maybe we'll just pick, to just limit the scope of change. I ran this on Spring called data flow earlier. There's still about 168 test files, and so thousands of unit tests that are still on JUnit4. I know the team's been working to get those to the JUnit5. So let's just do one piece of this. We'll do just moving the assert statements up from JUnit4 to JUnit5. And I've selected data flow here in advance, and we'll run this one. And so, here we're operating on an abstract syntax tree that's been computed and stuffed into the service to run this recipe. And if we look at the diff, you'll see that we're able to make these changes. Sometimes it's just import changes. And one of the things that we spend a lot of time on, and I think makes Open Rewrite really special, is that we do a lot of work to make sure that we maintain stylistic consistency with the project when we suggest a change. So if we're going to add imports or remove imports or change things, we're going to make sure it follows the style of the import style of the project around it. If we're going to make changes to like adding methods or removing methods, we're going to follow the indentation style of the original project, so that the change always looks idiomatically consistent in the context of the project it's being inserted into. We don't make any assumptions about you have to use 4-space indentation or this sort of thing. And so here you'll see, when you move from JUnit4 to 5, you have to go through every assert false statement and flip these arguments, right? It's just be super tedious to do this by hand. Changing these static imports where these static imports exist. Flipping all these. Sometimes, sometimes the original project used this static import prefix. We have another recipe that'll go and consistently apply a static import for assertions. You don't have this sort of mixture of assertions dot and assert equals, like the two different styles you see in the project here right now. But from this, we're able to take this and just create, create a pull request. If you do this with one of the Maven or Gradle plugins, you have an opportunity to just make the change on disk locally. So it's something you could do. You could run it. It would make all the changes locally on disk. You could review it there, run your tests or whatever, and commit it there as well. So here, if GitHub's API will cooperate with us today, we're gonna just create a new fork, actually, of data flow into my account, create a new branch, and I chose the branch name here, and then push all these changes you see up here up to the branch. And so here we've just been dropped into GitHub now, the sort of normal place we would be, and from here we could create that PR. One of the things that's real special about this, I feel like, is that changes by hand. You could spend hours on this kind of thing and prep a PR. You're not ready to merge the PR yet. Something else happens, and now you got merge conflicts again. And it's kind of super annoying. It's to have to go update it. Here, because the change itself was created via automation, it doesn't really matter. If the latest head changes, you just run the recipe again, and you are sort of rebased on the latest head. So you're able to make the big change, but the timing isn't as important as it is when you do it by hand. So let's look at a couple other things here in the actual app. So there's, in addition to doing these sort of transformations, there's also a search mechanism. So we could look for, say, here I want to know where I'm using the Guava collect, sort of list sets, all the static sort of builders that they have in Guava. I want to know where I'm using them, like the whole API surface area of that particular package. So it's an AspectJ-like syntax here, where we're just saying this, the receiver type. We're saying I'm even going to choose a wildcard for the last type, any method name, any number of arguments, and let's just run this on everything. So there's about 50 million lines of code here that this will run on, and hopefully everything goes well for us here. And so we're kind of already able to see some changes popping up where we're looking at like this Intuit repository, see what they're using. Cooperate with me. Go back here, maybe Iceberg. So you see, Iceberg's using this iterables.size. And this is where I think it's kind of a shame, right? This repository, and this is a test file, so it's not super important, but in many cases, there's a main source file that's using a library like this, a third-party library for one function that now has, because the Java SDK keeps evolving, it has a great alternative in the Java SDK. So now that's one more library that can conflict with versions of libraries in other parts of your application surface area and can cause a lot of inordinate pain. So one of the things we're really that we try to do is help write recipes that get you off of these third-party library dependencies when there's reasonable alternatives in the Java SDK. Yeah, so you can see these. We continue to find. We found, so far a little over 1,000 references to this particular API surface area. Immutable map.of. There's a you can use collections.emptymap instead, and everything would have been fine. There's plenty of examples of this now in Java 11, or maybe it was even earlier. But at least the LTS versions, Java 11, you're able to do map.of, right? So you wouldn't need to have this particular construct anymore. So let's actually use this as a starting point, maybe of where we could develop a different recipe, and one that performs a change. First, let's just try to do a simple sort of change. We've got core recipes like change type or change method name or change a target or something like that. So let's do something similar, but rather than just searching for the type, we could actually make a change. So suppose the Java util list add was changed to something called like increment or something like that, or plus or something like that. We could run this this recipe on everything as well. We see some changes coming in. We would be able to go and identify all the places where add was called and use plus instead. And the significance of the type attributed abstract syntax tree is that there's not going to be any false positives here. We know that this refers to a Java util list, even if that's not apparent from this file itself. I mean, this may have been coming from a parent class, that you were extending from, and so whose source is defined, maybe even in a third-party library, and not even in the same repository. So it's when you make a change, the idea is that it's always 100% accurate. So we'll hop over to the IDE and actually work out a recipe that performs another kind of change, which is a little more complicated, which is there's this Guava files type here. And they've got a create tempter method here, and note that they're even saying you could use just the regular Java standard library now if you could. So let's actually write the beginnings at least of that recipe for at least the amount of time that we have. So we're going to say no Guava files, create tempter.
Jonathan, we can't see your ID.
It's really strange. I shared my whole desktop, so I'm gonna maybe not share my desktop anymore. Do this. Now do you see the ID? I mean, actually, I just don't know if that's ideal. Do you see the ID?
Yes.
Yes. Yep.
Yeah, strange. Well, we'll work through it. Yeah, I shared the same content that I had before, but that's the you know, Vincent has like what the problems that started with you have sort of leaked over to me. The so we'll say no Guava files, create tempter. Like this is what we're going to try to affect here, and we're going to just say that this is going to be a recipe, and it requires a display name. This display name is what you saw over in the service. It would also show up in the Maven or Gradle plugins as you itemize what recipes are available to you. And we'll just say like use Java SDK rather than Guava files.create tempter. And you could add description text here that, you know, that would just say describe this, and you could even add like metadata tags if you wanted to help it be more discoverable. But we'll just create a visitor now. So recipes can contain visitors, and visitors are the things that are actually going to perform the work for us here. And so we're gonna have to kind of specify what changes we're making to the abstract syntax tree in order to affect this change. So we're just gonna, you know, maybe start with this. And before we go any further, maybe let's hop over and write a unit test actually for it. And we spent a lot of time on this unit test harness to make it easy to write good unit tests for the types of things that you're doing. So we're going to just extend Java recipe test here. And we're going to say no create tempter. We have a special function called assert changed here, and assert changed allows us to specify some before text and after text, and this text is going to be the code itself. The recipe that we're changing is going to be no Guava, you know, files create tempter. And then this isn't true for everything or every type of recipe you may write, but this one specifically, we're making a change where we're assuming that the before code uses Guava. So we're going to override the parser that the test uses to actually parse the before text. And we're just going to pick a dependency off the class path, which is Guava, and say we're going to use that one. And that so that it'll be available. And so here it's kind of magical. We can actually write just Java code in this string where our unit test harness is using this handy language annotation from JetBrains, so that the IDE will actually syntax highlight and help complete the code in the unit test itself. And we're just going to add just kind of a dummy method in here as well. And so far they're the same. So let's see. I think if we were going to create a tempter, we'd do something like this. We would say files.create tempter. And notice it's using that. And kind of the IDE does funny things with these imports. The IDE is even telling me, you know, at this point that, you know, this is not necessary, but that it could be replaced. And of course we know that as well. But if I was trying to apply this change across my whole org consisting of 100 million lines of Java code, you know, using the recipe, I could sort of achieve that really quickly as opposed to opening every project in an IDE. So there's one more import we need, which is Java util file or Java IO file, of course. And this is the before, right? And so afterwards, what we would like to see is files dot and different files, right? Not the Guava files, but this was the original one. Here they're saying use Java NIO files create temp directory. So we really want this Java NIO files. And this one's a little weird. We've got like a prefix. I kind of peeked into this implementation, and basically what they do is do this. And this is more or less the replacement that's suggested at this point. I think, you know, in many cases you would choose some other string here, but this is sort of the drop-in replacement for what Guava was doing here, without needing to use Guava. So notice, unlike what we just did with change method name, where we changed add to plus, here we're changing like not only the type, but we're creating a very different structure to the code than existed previously. And this is the whole unit test. So this is, we're done with that at this point. If we come over here to the visitor, I have to identify where in the abstract syntax tree I want to make my change. And here it's to a method call. It's to a particular method call. So maybe let's just visit method implications. We use the visitor pattern here, and we want to determine if this method, as it's being visited, is the one that we want to change from. And so for that, we're going to use something called method matcher. It's a little utility that allows us to identify the original method. And again, this is that Google Common IO files, create tempter, had no arguments. So that'll be the basis of our matching logic. And then down here, we can say, if this matches this method, now I know I'm in a place where I want to make a change. So how do I go about making the actual change? We have and I don't want to have to, know how to build up the whole abstract syntax tree for what all this means. So we have a nice utility called Java template. And this is going to be, just say, what's called tempter. And here, I'm going to be able to provide the code that looks like what I want it to look. Create temporary directory. Just copy this from over here. This is the code that I want. And what this Java template will do is it'll use the Java compiler actually to create just this little abstract syntax tree that I can then insert in a different place. So I can use it to replace this existing method invocation. So we have to help it out a little bit. We have to tell it, like, what do I mean by files when I said files here? And for that, we'll add a, whatever this type is, Java NIO files. This is what we mean by files when we say files here. And these are coming from java.lang, of course. So there's no need for an import there. And that pretty much is it for the template. Now, how to use it, we can say return method, the original method with template, and we're going to say tempter here, and we want to say method.getCoordinates.replace. So we're going to replace the whole method. And we have this coordinate system to help you, generate, so you can use coordinates to like insert the last statement into a method body, or, change I could have said arguments, replace all the arguments of this method instead. So you can kind of dot in through the coordinates and look at what sort of things are available to you to template out. And then, there's a parameterization mechanism here at the end. You can supply arguments to these templates. Some of those arguments can come from the original code. Some of them, are from the program here itself. But we don't need any in this case. So that's part of it. And we're just going to say, I'm going to return the replace method invocation. So there's one more thing we can do, which just helps. You could have a file that's thousands of lines long, and that has lots and lots of methods. So this isn't necessary, but just as a quick way of making the whole thing run faster, we can say, I'm just going to skip the whole file if it doesn't use somewhere in it this Guava create tempter signature that we are really wanting to change. And so if you're running a bunch of recipes in sequence, this information about what's used gets cached at the top of the AST. And this helps you run over, thousands or millions of lines of code, as you saw us doing a little earlier, in a very efficient way. but again, strictly optional. And so here, these are the sort of changes that we wanted to see. And so let's see what happens when we run this test now. We've gotten some of it right. So the test failed, and let's, we can just use the expected versus actual here to see what changed. So I was expecting create temp directory, and instead I created this. So I think I just made a mistake in the test here. I meant to say temporary directory. So that's fine. We could change that because that's the actual call. And then let's look at this diff again. So I've still got the wrong imports up here. I've still got Google Common IO files, and I haven't added the new one. And so for this, there's one more change we need to do to the recipe. Here we'll say, maybe remove import. And we say maybe because I don't know at this point when I'm making this replacement whether there's going to be any other legitimate uses of Google's files class or not. So what this is basically saying is, if there's no other usages of it, go for it. Go ahead and remove the import. If there is, don't touch it. And that helps. And then we'll do the same thing on the other side, which is, maybe add an import on files. And we'll run this one more time and see what happens. I think we're getting closer. Let's see. Got long. I wonder if I actually got the right type here. Java NIO files. Create temp. Oh, so it is create temp directory, not create temporary directory. And so let's make that change. So basically what the test was telling me is, hey, you generated some code, and that as the compiler generated that AST, it wasn't able to find this symbol. So, the test really caught that mistake early. It didn't allow us to make that. So the test here was originally right. I'll run that one more time. And that's it. So this one passes now. And this would be something that we could then ship as a recipe. We've been developing a lot of these, and if you look at the various projects, you'll notice that there's different ways of packaging these. You could take this Java file that we just created, and of course package it in a jar and ship it, and use one of the existing plugins. There's a doc site here on docs.openrewrite.org where we say if you want to run a Maven, or you use the Maven or Gradle plugin, you just apply the plugin and then activate a particular recipe to run, and then just run the task. This would make these changes on disk for you to see. So in this case, it would be this, org open rewrite Java migrate guava, and the name of this file would be the recipe name that you would activate. And otherwise it's the same. But one of the things that is also pretty special, I think, is that you can just ship in your meta-inf rewrite directory, you could ship any of these YAML files, which you can use to specify a really common sorts of operations. Like in the case of JUnit 4 to 5, we do, there's probably a change type in here somewhere. We do like change type from assume to assumptions. So I didn't have to write any code for this. I just specify what the original type was and the target type. There's things for reordering arguments, for manipulating imports, for changing types, for changing methods, for doing all sorts of different types of things. And so then you could just put it in this meta-inf rewrite, which means that the project wouldn't even need a dependency on rewrite and ship it. And the Maven or Gradle plugins would be able to scan the class path and look for those recipes and make them available to you. What we'd love to see, and I think there's some movement in this direction, what we'd love to see is that open source teams like the Spring team or the Quarkus team ultimately develop recipes to help migrate you, the user of those frameworks, from one version of a thing to another. So that the moment you pick up a new dependency, say you pick up a new version of a dependency, the change is available to you to run. And it's, sort of, rather than just deprecating something and, providing some documentary advice or writing a sort of migration guide, that they would actually write the recipe that you would then apply. And that's the sort of future that I think we want to see, getting everybody back to more creative work and not doing these things that are by hand. At this point, there's a lot of different directions we could go with this talk, but I think it'd be a good stopping point and a place where I'd like to invite some discussion and questions. And what do you think?
Simply awesome.
Thanks. Yeah.
I try to do a lot of refactoring using regular expressions. So the previous example that you gave, right, the log formatting, I have done myself. It was a pain in the whatever.
Yeah.
So yeah. So I have been. This is something that very great. So it's a open source, is it?
It is. Yeah. I'm going to show that that again, just a little slower this time. So it is, the main repository is out here on rewrite. Or open rewrite. Yeah, we'd appreciate your, look at this here. If there's something that you have in mind, saying like, I wish I could go do this thing, like open an issue, and that's something that just you're welcome to write a recipe and contribute as well. But we're also just want to know what you want to see, and we'll develop accordingly as well. So
nice.
So this is obviously a Java users group and everybody's a Java user, but is there any thoughts about looking at other language spaces as well?
There is, and we've been moving in that direction already. Of course, to support the Spring, 1 to 2 migration, for example, you also have to change properties files and YAML files because they've moved properties. So we do have YAML properties, XML building blocks, a lot of building blocks being developed there to do that sort of work as well. Recently added something very different, like Terraform one, and here I think we have this TerraGoat repository. And I think this is the first of its kind, sort of, automatic Terraform repairing system as well. So that's out there. This is sort of a geeky thing, but I think Groovy is coming really, really soon. And with it, Gradle auto remediation. One of the things I'm super excited about is that since Groovy is largely a superset of Java, we get to use all the same base recipes that we already have in Java on Groovy. So when we finish up that AST mapping from the Groovy compiler, we'll be able to change method names, mess with imports, change literals, do like all these base things that we can do already with Java, just like we'll get for free on Groovy. And I look forward to writing a Gradle wrapper around that, that will also do like dependency management tasks, plugin management tasks, configuration changes, a lot of the tedious stuff that we know is involved in Gradle builds. The thing that probably is less obvious is that around some of these base things like the XML AST, we've also layered a Maven AST. So you could do something like search. You could do something like search for any Jackson module on the compile scope, and I don't know. Let's look at the Spring repositories or something here. So 31 repos, good enough. I think we'll probably find Jackson somewhere in Spring. Don't you think? You know, so sure, you know. And so here and this sort of eliminates something that we didn't talk about, but here I've said, you know, Spring Cloud Starter Gateway uses Jackson module parameter names 2111, you know, sort of here. It's pointed out where it is in the POM that thing comes in. So as opposed to using like Maven dependency tree, where you have to sort of map what you see there to what's in the actual POM files, here it's going to point out the exact line where it came in. We could go much further with this, but yeah, this is a you know, super exciting to me. So we have like add base recipes around upgrade dependency, add dependency, remove dependency, exclude dependency. I did one once where I was like exclude, maybe go into core here, JUnit from the compile scope, right? Where it shouldn't really be. And it was weird all the places where you found it sort of leaked onto the compile class or runtime, you know, it shouldn't be on the runtime. And those are the kinds of things I think that I would like to see, you know, us run in perpetuity almost, you know, these recipes that keep our dependencies a bit cleaner. So when the Groovy AST lands shortly, you'll see a Gradle AST wrapped around that Groovy one, just the same way. And then one of our team members just really undertook the effort of doing JavaScript Typescript as well. And so there's some really early indications that that's going to be pretty awesome as well. It's since this is a Java user group, we're going to actually be able to run, you'll be writing JavaScript recipes in JavaScript, unlike we just wrote a Java recipe in Java. So trying to make it a native experience for each stack. But that JavaScript recipe will run on the JVM actually when it runs. So it's, you know, we'll be able to sort of use the same mechanism to distribute those recipes that we do for the base Java recipes as well. That was kind of maybe a long answer to that question, sorry. But,
yeah, it's awesome stuff. Thank you.
Yeah, what other thoughts are out there? Yeah.
John, I'm curious about the difficulty in creating new ASTs.
Yeah, it's, you know, if you've done 3 or 4 of them, it gets easier. Not the easiest thing in the world. You know, I like to, I'm an engineer, I've been an engineer for a long time. And if you ask me how hard is something going to be, I'm always going to say, I can have that done in a few days, but it'll be sometimes harder than that. I really thought when I went after this, when we did this HCL Terraform AST, I thought, oh, Terraform is just an extension on JSON, right? How hard can it be? And it turns out Terraform is a very complex language. I think accidentally complex, but you know, you get to parts of the reference doc of the language where they say, we can't specify this in EBNF, so we're going to describe it in prose, and it just made me like scared, right? But yeah, it's AST adding is not easy, but I think the harder thing is actually it's not so much the AST, it's understanding all the idiosyncrasies of a language. So when I go to add a dependency, if the dependency, if it's this Maven, for example, if the dependency is already specified by a parent POM dependency section, don't add it. A Java developer wouldn't add it. They would see that it was already present somewhere in an ancestor and they wouldn't add it. So it's, but the, you know, the NPM dependency system is very different. You know, Golang's dependency system is going to be very different. Or maybe it'll follow the same path that Java did. I don't know, but hopefully not. So I think that's why we're sort of treating it language by language, is to get all those idiosyncrasies right. You know, recognize that there's 25 years of Java development here, that styles have changed over time, and we want to respect those styles.
Nice.
Yeah. Hi. think I saw Brad on.
More questions, folks?
Yeah. Maybe not.
Let's go check the chat. So yes.
Oh yeah. Oh yeah, of course. Cool. Yeah.
All right, folks. Let's see if we can get some more questions for Jonathan based on his presentation and code demo. Just having a look to see if anyone posted anything in chat. Doesn't look like they have.
Yeah, feel free to just jump out there and say, this is what I'd like to see, or, you know, I doubt that this can work, or, you know, like, been doing this for a while now.
Yep. So if you don't feel like turning on your microphone, you can always drop something in the text chat too. If you have a comment or a question for Jonathan. Okay, here we go. Hey, not sure my audio came through, but was curious as to what extent you've looked into integrating this more incrementally as part of a build process to ensure people don't reintroduce outdated models. That's from Bradley Wagner. Yeah,
thanks, Bradley. Yeah, your audio wasn't coming through earlier. We saw you unmuted, but I didn't hear anything. I think what we showed there with the Maven and Gradle plugins is there's a build tool task, there's a rerun, there's a dry run as well, which would just, you know, you could select a series of recipes and dry run and basically say like, I would make these changes were you to actually run the run task. And the goal there is to give you a task that you can hook into your build process to use as a more of a gating function if you care to. So you could, you know, you could run a certain set of high value or like recipes that you do not want to see a pattern reintroduced and say, you know, fail to build if dry run comes up with anything. We do understand that there's a lot of variation out there in, you know, the ecosystem in terms of like how much we build guardrails versus gates. And so that task is, we didn't automatically hook it up to the check, you know, task in the Gradle lifecycle or the test lifecycle in Maven. So it's just kind of up to you to do so if you want to take a harder stance on some of these things. I think it makes a lot of sense. Yeah.
More questions for Jonathan?
I have two questions. One is, can we, you know, use this recipe to, or any recipe to, you know, change the extension, the inheritance?
Yeah, change inheritance. Like, do you have a concrete example in mind? I'm curious.
Like, you know, the base class or, you know, interface that they have is outdated or deprecated. So we want to use a new interface or a new abstract class to extend. Okay. So something that they have deprecated.
Yeah, you can change literally any part of the AST, which does, I'm trying to think of an example where we do this already. And I think there may be some examples in Spring where we had to change, where they did a deprecation of let's see, just look through the catalog here.
And along the same lines, right? Can we change the annotation as well?
The annotation, absolutely, yeah. So that's, and those things are usually pretty simple. It's like you could do a, you could just do change type, like org.junit.test to org.junit.jupyter.api.test. That one's not quite that simple, of course, because some of the parameters have changed. And so we do have a recipe that encapsulates this change. But, you know, if this is an annotation, it'll hit an annotation. If it's not, it won't, it'll hit something else. So yeah, that's, and we do the same thing really with implements or extends. Anywhere a type reference could be in the AST, change type would make that change. And then if necessary, it would also manipulate the imports. And And so that's a change type is a really good example of how we're building layers of abstraction towards more complex things. If you change a type from, one thing to another, the import for the old thing may have been under a star folded import. And maybe your rule in your project is any more than 3 types from one package should be star folded. Now, by removing the use of that old type, there's only 2 remaining. And really, I should star unfold that. So now I wind up inserting 2 AST elements realistically that have nothing to do with the change that I'm making. It's just the other 2 types that happen to be, implicitly star unfolded there. And then when I go to add one, maybe the opposite happens, where I only had 2 types, now I have 3, and I need to collapse those into one. These are things that the IDE does for us all the time, of course, but that, we've sort of built those base building blocks as well that would allow you to do, change type and then not worry about the way imports are treated or respond to the style of the project that it finds.
Okay. And then the second question is like, has any company used this tool for, refactoring? And then did you get any feedback about that?
We've been working with a number of design partners for a little over a year now. And some of them, some of them are more recent. And we've seen some pretty significant changes on a spectrum. So the JUnit 4 to 5 recipe was developed and tested with one of these design partners. One of their repositories had, many thousands of unit tests. It's almost going to be a familiar story, but they do sprint planning every 2 weeks, and the team said, we want to move from JUnit 4 to 5, but the business said, we're not going to make that a priority right now. So the team agreed, anytime I touch a test, I'm going to move to JUnit 5, and gradually we'll get there, right? And 18 months have passed, and they're 20% of the way done. So they ran that JUnit 4 to 5 recipe, and they were just done, right? So that's a pretty significant difference, in the time to just being done, We've been doing a lot of recipes around, like, if you have like a sonar cube or something like that, it tends to report a lot of like, don't do this, don't do this, don't do this, rather than it just being a flag. We have a recipe that will go auto remediated. Sometimes those things there can just be thousands and thousands of these occurrences. And so we've been fixing a lot of that. And then we've seen some interesting internal recipe development as well. One of the early, I guess, like private design partners actually makes API calls against Launch Darkly, the feature flagging system now. And whenever Launch Darkly says a feature flag is not used anymore, they go rip out the feature flag from the code. So that's a good example, I think, of where you can integrate a live production system with something like this to make changes back in the code.
Does it have,
it's been kind of all over the place.
Speaking of SonarQube, do you have the recipes for SonarQube flaws that it the smells and other things that it finds, right?
Yeah, I mean, I wouldn't say all of them. Of course, there's over 1,000 of them, I believe. But it's just, whenever anybody says this SonarQube recipe is important to me, we go build that one. So if you look at your top 5 right now, like, go open an issue on that, and one of us will get around to it. We'll develop a recipe for it.
Sure. Yeah. Thanks, Jonathan.
Yeah.
So, Jonathan, I have a question.
Sure.
Instead of modifying the existing file, can you use the pattern matching to generate a different file? What I'm thinking is, if you've got a large code base that has no tests, it would be interesting to be able to generate something that just gives you some stubs that you can get started with, so you have some ideas to just how big the mess is going to be to try and clean up.
Yeah, you absolutely can. And one other example that's other than tests is where we see a Spring XML file. We want to take that XML file and then generate Java configuration files that that represent all the configuration we found there, and so migrate ourselves away from that kind of thing. The recipe class itself, I'll open it here. well, I guess it's not super important to show it, but the recipe class itself takes in a list of source files and it returns a list of source files more or less. And so as a recipe author, you have an opportunity to just add another thing to that list, or to remove something from that list, conversely, if you want to delete something. Or to take the, on the top level AST element, which is different for each language, but for Java, it's j.compilation unit, there's a source path as well. So you could relocate or move a file from one place to another as well. So really any of those things should be possible.
So you could potentially then also take like a JEE application and make it a Spring app.
Yeah, I think that's, and we see some of that development already. In all seriousness, like I know VMware has a little bit of engineering work going on that right now, and Red Hat's considering it as well. And I love the idea of framework authors really getting after this. Like, you know, IBM Red Hat wants you to go from JEE to Quarkus. You know, VMware team wants you to go from JEE to Spring. I think they should each, you know, work on that individually. Yeah, absolutely. Of course, those kind of changes, you know, they seem really, really, really hard. And I think the more base recipes that are built, the easier those kinds of things get. So what JUnit 4 to 5 seemed really hard a year ago, and now seems pretty obvious. It'll be interesting to see what happens in another year or two.
Cool, thank you.
So there's a question about, you know, is there any hesitancy by Java developers to use this kind of tool to refactor code? We've had to use a tool that was very similar and gotten some pushback. I think pushback is very understandable. And so I think the best place to start, like any technology, is to start small. So, you know, with something that's easily reviewable. So, you know, one of these recipes that does, like, this is what I did with the data flow team. The first PR I opened was just consistently use a static import for assertions. It's easy to review. You know, it's not going to break any core functionality. But yeah, look, it you know, it obeyed the import ordering layout that we had. That looks really interesting. And then you kind of work your way up to more and more complex things. What I love about this model of encapsulation, where we have like Spring Boot 1 to 2, is really just a composition of all these individual recipes, is that you can run any of those individual recipes on their own, and, you know, and in that way sort of build confidence, you know, incrementally. So.
Okay. Cool. More questions for Jonathan?
Hey, John, have you thought about any way?
Great questions.
Hey, John.
Yeah, go ahead.
We can hear you. Go ahead.
Okay, sorry about that. Yeah, have you thought about any way to sort of automatically run a bank of recipes against a repo rather than having to go select specific ones? I'm sort of thinking about GitHub's Dependabot, where it detects particular out-of-date dependencies and suggests pull requests. So just curious if you considered anything like that.
There could be more development on this in the future, but what I've observed so far is that with those applicable tests that we showed earlier, just like don't really navigate to AST if it doesn't use this method. If those are applied fairly well, it's really fast to just run them. So you can't just take the approach of just run them all.
Okay.
and then there's really no issue. When I showed that example earlier, that was, you know, 50 million lines of Java code that was being navigated. So it's quite a bit.
Very cool. Okay.
Yeah.
All right.